Hi folks, and welcome back to Physics with Captain Rod. The purpose of this video is to help demonstrate how to write Newton's second law equations in two dimensions. So what I have over here, this is a theoretical free body of an object with four force vectors acting on it. F1 at 60 degrees, here's F2 to the right, F3 here 30 degrees from, let's say, the negative y-axis. F4 here is 25 degrees from the positive, or up from the negative x-axis. All right. Well, the purpose of this video isn't about how to draw the free body. All right. I'm going to have other videos for how to do that. The purpose of this video is how to handle or how to write the Newton's second law equations for a two-dimensional type of free body. And the first thing to realize here, right, Newton's second law, force equals mass times acceleration. I've got it written out right here. Newton's second law is a vector law. And when the problems get complex, I like to draw one picture showing the force vectors, which is what we have, here on the left. And I like to use a second picture for the other side of Newton's second law, for the MA types of terms. So the acceleration of this object right here from the forces shown really is not known. But, let's say it might look something like this up and to the left. When the acceleration is not known, it's quite customary to deal with things in terms of components. So what I'm going to do is I'm actually going to put a pair of vectors here and here. This one is going to be for the acceleration in the x direction. This one's going to be for acceleration in the y direction. And what I'm going to do is actually put a mass in front of it. MAX, MAY. And the reason is because I want this picture to basically be the right-hand side of Newton's second law. So since Newton's second law is net force equals ma, I want my picture to kind of graphically reflect that. So the picture on the left is the picture I'll use to deal with the left-hand side of Newton's second law. Then the picture on the right is what I'll use to write out the right-hand side of Newton's second law. So here's what that would look like. To find the net force, we're going to sum forces by summing components. So one equation I can write is this. Sum of all forces in the x direction equals mass times acceleration in the x direction. I'm calling to the right positive. So looking at this free body, right, if I look at F1, and if I wanted to, I could write F1 in terms of components this way and this way. So this is what I would call F1x, and this is what I would call F1y. And when you look at that picture, F1x is adjacent to what I'm calling the x direction. I'm sorry, F1x is adjacent to the 60-degree angle, with F1 being the hypotenuse. So F1x is equal to F1 cosine 60. F1y is equal to F1 sine 60. So I'm going to go ahead and use those values here. I'm going to get rid of this for just a moment. All right. When I write my equation here, we're going to have, let's see, F1 cosine 60. That was for the x component of F1. Right. F2 has an x component, so I'm going to put plus F2. Now, because F2 is parallel to the x-axis, there's really no sines or cosines required. Right. Now I'm going to take a look at force 3. Force 3 has components that could be drawn like this. This is what I would call F3x, and it's equal to F3 sine 30. Right? The other force component would be F2y equal to F3 cosine 30. I'm going to go ahead and get rid of these before I move on. Right? So now when we write our force equation, right, getting back to summing forces x direction, the x component of F3 is to the right, and its magnitude was F3 sine 30. Okay. So that term is coming from the red force component that was right there. Now, F4 also has an x component. I'm going to kind of sketch these components in red. F4x would look something like this. F4y. Right? F4x is adjacent to the 25, so its magnitude is F4 cosine 25, and it points left. So let me get rid of this stuff here and get back to writing the equation. So we're going to have minus F4 cosine 25. And I think I've taken all of them into account. So equals MAX. Right? Basically equals this. to write the y direction, let's see, sum of all forces y direction is going to equal ma in the y direction. I'm going to go ahead and call up positive. And again, if we think back to when I drew the components for force 1, a little reminder, they were right and up. This component is now equal to F1 sine 60. Right, so I'm going to use that when I write the equation. Right, so first term I'm going to have here, F1 sine 60, right, plus, now let's take a look at force 2. Force 2 does not have a y component. I'm going to go ahead and put plus 0. Okay. Now let's take a look at force 3, and again, if I put those components in, F3y, F3x, F3y is adjacent to the 30 degrees, so it's going to have a magnitude of F3 cosine 30. Right? When I come over here to write it in the equation, I'll go ahead and remove it for now. Now also, the y component of F3 points down, and that's why when we write the equation, minus F3 cosine 30. Okay, let's go back and take a look again at F4. F4's components, remember, they look like, oops, I like to do those in red. They look like this. There's the x component, there's the y component. Take note that the y component is opposite the 25-degree angle, kind of a crummy little triangle, but humor me. So when we write the force equation and we include the y component of F4, it's going to be positive because it's up. F4 sine 25. And that's it. We've taken into account the y components of every force, so I can now write equals ma in the y direction. So in theory, what we could do with this is, provided we knew all these forces, this sum is going to give us could give us a number. Divide by the mass, we would then have acceleration in the x direction. This sum, provided we knew all these forces, would give us a number. Divide by the mass, we would have the acceleration in the y direction. So that's how you write the Newton's second law equations, right? You draw the free body. That would be done first. If it's a fairly complex problem, I usually put a second part to the free body over here where you draw the ma vectors. And I said that plural because there can be several of them. You write one force equation for the x direction, one force equation for the y direction, and pretty well that's it. So I hope this helped illustrate how to write these force equations. Have a great day.